Very good. So good afternoon, everybody. My name is Gary Stafford. I'm a solutions architect here at AWS. I've worked closely with Dipti and Steven and the rest of the Ahana team since their inception. And then I was lucky enough to work with Steven and Dipti as part of some of their previous endeavors. So we've known each other for a while and their work on the AWS platform. I'm going to briefly discuss two topics in regards to Ahana Cloud and then turn it back over to Dipti to dive a little deeper into Ahana Cloud specifically. So I'm going to talk about the integration with AWS. First off, I'm going to talk about Amazon EKS, which is our managed Kubernetes service, which is the service that Ahana Cloud uses to deploy, Ahana uses to deploy Ahana Cloud on AWS. And secondly, I'm going to talk about what Ahana is calling their in-VPC method. So Amazon Elastic Kubernetes Service, or Amazon EKS, is AWS's fully managed Kubernetes service. So if you're a user of Kubernetes and want to get started with it and don't want to do all the heavy lifting of setting up VMs and deploying Kubernetes on any of the cloud platforms, each of the cloud platforms has a fully managed Kubernetes service on Amazon. That's Amazon EKS. Amazon EKS runs upstream Kubernetes, so it is a certified version of Kubernetes. It's Kubernetes conformant. Currently, Amazon EKS includes versions 1.15, 1.16, 1.17, which was the current default last time I looked this week, and then 1.18. And then each of those versions are supported for approximately 9 months after its release on the AWS platform. So you have time to upgrade and pick the current version that you want to work with. Very quickly, at a high level, obviously a lot of moving parts with Kubernetes and with a fully managed Kubernetes service, but Amazon EKS is a fully managed service. The cluster consists of 2 VPCs. If you're not familiar with the term VPC, I'm going to discuss that. I'm going to discuss that in a minute, so just hold on. But 2 VPCs. So the first VPC is managed by AWS, and that hosts the Kubernetes control plane. So if you're familiar with Kubernetes, the control plane is in a VPC, which is controlled or hosted by and managed by AWS. And then the second VPC is managed by the customer that hosts the Kubernetes worker nodes on EC2 instances, which on the AWS platform are virtual machines, which host the worker nodes, which in turn host the running containers. The Amazon EKS control plane has a number of responsibilities. Some of those major responsibilities include automatically managing the availability and scalability of the Kubernetes control plane. It's responsible for stopping and starting the containers that are deployed to the cluster. And when I use the word cluster, I'll stop there for a minute because I know we're talking about Presto today. I'm talking about a Kubernetes cluster as opposed to a Presto cluster, which in the Ahana case is running on the Kubernetes cluster. So hopefully that doesn't confuse anybody, or maybe it confuses some people more, including myself as I'm talking about it. The control plane is also responsible for scheduling containers on the VMs or the EC2 instances, the worker nodes. It's responsible for storing the cluster data, and then it can automatically detect and replace unhealthy nodes. So part of that undifferentiated heavy lifting that AWS likes to say that we do with our fully managed services, so you don't have to worry about detecting and replacing unhealthy nodes. I grabbed a quick picture here from one of our available deployment configurations. There's a number of different ways to deploy Kubernetes, public, private, or a hybrid of public and private. This is just one typical example. So you can see the Kubernetes worker nodes deployed across 3 availability zones within 1 VPC so that it is highly available. So if one of the availability zones go down, maybe it's US East 1A, there's still 2 more availability zones to provide high availability to the cluster. And again, why are we talking about Amazon EKS? Because Amazon EKS is the primary service which Ahana Cloud uses to deploy its Presto cluster and the other applications that are part of the Ahana Cloud solution. And then provisioning EKS, relatively easy. There is a networking component to creating or using existing VPC, assigning subnets, understanding networking is certainly important, and then creating security groups to make sure that the cluster is secure and you control the ingress and egress to that So think of it as a virtual firewall. Who has access to what through what port? Again, a couple different configurations. What we're going to see with Ahana Cloud is Ahana Cloud takes care of all of this. So there's you don't even have to push any buttons. You give secure control to Ahana Cloud. They deploy the cluster within your account, and it's up and running in the background. You really never have to interact with the cluster. So second thing I'd like to talk about before turning this back over to Dipti is Ahana Cloud's in-VPC deployment method. So that's a term that the Ahana team has coined, and it really incorporates a number of features, security and networking features that are available on AWS, and it's the method which Ahana uses to deploy Ahana Cloud into a customer account. So quickly, I think in my opinion, what makes Ahana Cloud unique and a great solution for customers, it really brings together the best features of a SaaS provider and the best security features of the do-it-yourself model on AWS. So, if you go with a SaaS analytics engine, not all of them, obviously there's a number of variations out there, but a number of analytics engines. So if you get analytics as a service, it's a fully managed service. Again, you don't have to do any of that heavy lifting. Somebody takes care of setting up and managing the cluster. Somebody takes care of security. Somebody takes care of setting up and logging and monitoring for you. You don't have to do that hard work. The only thing you give up oftentimes is loss of control of your data. So in order to use an analytics as a service SaaS solution, oftentimes your data, in part or all of that data, is being copied or cached to the SaaS provider. Again, not in all cases, but in many cases. With the do-it-yourself model, the advantage or disadvantage, depending on how you view that, is you're building it, you own it, you're managing it, you're patching it, you're maintaining it, you're setting up logging and monitoring. So there's a heavy lift often on the individual, the customer's part, to configure a highly available distributed analytics engine within their AWS account. The advantage is you retain full control of your data. So if your data is housed within your AWS accounts, then you retain full control. The data never leaves your account. The beauty of Ahana Cloud is they really combine both of the best features between SaaS and do-it-yourself. So with Ahana Cloud, you get a fully managed service that's deployed to your account. So everything is within your account, which means you retain control of your data. And Dipti will get a little deeper into this. I mentioned the Amazon Virtual Private Cloud, or VPC. That is the logical construct, or the isolated section of the AWS cloud in which the EKS cluster runs. And on the EKS cluster is where Presto is running, which Ahana has installed as part of the Ahana Cloud solution. So it's a private block of IP4 addresses. It's within your account and within a particular region. So oftentimes customers will have multiple accounts, and oftentimes companies will deploy resources to multiple regions depending on where their customers are, or where they need to maintain data locality and govern where data is housed. So you have the ability to deploy the Ahana Cloud solution to the region that you want, and to the region oftentimes where your data is. So how does Ahana Cloud do this? The way they do this is by delegating some access to Ahana Cloud, and in return, they will deploy AWS resources securely to your account. So again, without going too deep, identity and access management, authentication, and authorization is a broad and deep subject, and certainly there's a lot of people smarter than I am that could get into a very technical discussion on IAM on AWS. But at a high level, there's an assumed IAM role. So Ahana Cloud provides you with a blueprint with a JSON template for a role. The only work that you have to do to get started with Ahana Cloud is create that role and then provide the unique identifier for that role, or the ARN, back to Ahana Cloud. What that does is it gives specifically Ahana Cloud, and specifically one account that Ahana owns, access to your one and only account as a third party. It uses temporary credentials, so they're short-lived credentials. And we also use an external ID. So in addition to the security that those temporary credentials offer you, using our security token service, we use an additional external ID to guarantee an additional level of security. Using that assumed role, Ahana Cloud will deploy all of the assets necessary to stand up the EKS cluster, and then on that EKS cluster, deploy Ahana Cloud, which is the Presto cluster and the additional resources onto that. So you can see here quickly, I won't get too deeply into it. This is just an example. I've created that trust relationship between, in this case, my account and the Ahana account. I provided them very specific capabilities, policies, permissions to particular services within my account. And that's the only access they have. And that's the access which Ahana needs in order to deploy, manage, and maintain Ahana Cloud on the customer's account. And that can be revoked at any time. Obviously, if there's any security concerns, the role can be reviewed ahead of time by your security teams. And then if there is any concern whatsoever, that role can immediately be revoked. The external ID could be changed, so it provides a high level of security. And then the last thing here, this is the end result. So Ahana Cloud, Ahana has deployed resources to the AWS account using CloudFormation. So if you're not familiar with CloudFormation, maybe you're familiar with Terraform or any of the other infrastructure as code software solutions out there. CloudFormation is AWS's infrastructure as code. And in this case, Ahana Cloud has used CloudFormation. So everything is infrastructure as code. I can go in and look at any of these CloudFormation stacks. I can inspect them ahead of time to make sure that they meet my security team's requirements and governance controls. Those are then deployed. At any point, I can undeploy those, although it's obviously easier to go through the Ahana interface to remove resources. I'm going to turn back over to Dipti.
Dipti, you're muted.
All right.
Good. Perfect now.
Perfect. Thank you. So now that you know a little bit more about EKS, let's dive into how the Ahana Cloud itself works. So at a high level, many of you are probably managing Presto yourself. It is, given that it comes out of the Hadoop ecosystem, it can be fairly complex to manage. And with Ahana, what we've tried to do is really simplify that with PrestoDB as the core engine, as the distribution that we use, and we have built in a managed service around it. So you don't need to manage your own catalogs. You can use the Ahana Managed Hive Meta Store, for example, comes with built-in S3, and also built-in configuration parameters for a range of different things like the catalogs, as well as for the config properties itself. So the setup is pretty straightforward. The first thing you do is you sign up into the SaaS console. Once you've signed up, we do the cross-account access with your AWS account, as Gary was just talking about, with this in-VPC approach. So it's a managed service that is deployed in your account so that we bring compute, we bring Presto into your account where your data is. And so that makes it secure. But at the same time, you get all the benefits of a SaaS system, which is orchestrating, managing, deploying, and managing Presto for you. Once the compute plane is ready and ready to go, you essentially can create any number of Presto clusters within that compute plane to access your data sources on AWS. So the Ahana SaaS console is responsible for the cluster orchestration, consolidated logging. Everything comes pre-integrated so that you don't have to deal with managing this. For example, server logs, coordinator logs are automatically integrated with the CloudWatch. The query log, which you would typically have to write in Java code with for the event listener for, is pre-integrated as a plugin, and the query logs are available in an S3 bucket, as well as pre-connected with every Presto cluster so that the admin has full access to this. And you can use Presto to query your query log that Presto has generated. Security and access is built into that as well as billing, which goes directly through the marketplace. And so it's a pay-as-you-go model. You only pay for what you use. The compute plane itself is where Presto runs. You can run multiple clusters and connect to a range of different data sources. We see S3, RDS with MySQL, Postgres, Redshift as the most popular sources on AWS. And you can also connect with your Glue as well as and your own Hive metastore if you have an external Hive metastore. So the SaaS console manages the compute plane internally, and you have the options of using connecting with all your data sources. All of this is running within that EKS cluster that Gary was talking about. And so you're never moving your data. It's all in place querying with Presto, obviously. The queries use the PrestoDB connectors to these various data sources and pull the data and that's needed, push down predicates as needed based on each connector, get access to the data. That is all in memory within the Presto cluster. And then you return the results via JDBC or ODBC drivers to your BI tool of choice. Ahana also comes in bundled with an instance of Superset. It is again running in your VPC, and so the SaaS console, the control plane, never has access to any data. There's never any user data that moves in from the compute plane into the SaaS console. So a little bit of how it works. You can create clusters. You can add with a few clicks the data sources that you'd like, and it automatically restarts the cluster for you. Sometimes there's a lot of management that needs to be done. When a catalog is added to Presto, you have to manually restart the cluster, and as well as for some of the config properties. And so that is made very easy with click button kind of experience. You can also stop clusters, start clusters after that, and all your metadata about your configuration, the data sources you've pre-connected, is all maintained. So you don't really lose that information. All the coordinator and all the workers get deprovisioned, and when you want to start back up again, your configuration is maintained. So you're never having to redo any of the configuration properties. So let me actually jump to the product itself and the SaaS to show you what that looks like. So here is where you would start typically. This is the cross-account access. We give you access to the Ahana credentials, and you bring in your role ARN that you want Ahana to assume and create the compute plane for you. You pick, you can pick the region that your data sources are in. So you want to be get the compute close to where your data sources are. You pick a couple of different AZs. EKS by default is spread across multiple AZs, and so you pick at least 2 so that you have the ability to have a scale and a high availability for the EKS clusters, as well as Presto. You give a domain name and you go from there. Once your compute plane is created, it's very easy to get started. So here you see I have a few different clusters up and running. You obviously have access to the PrestoDB Console, which allows you to see what is going on in the cluster. See the this would look familiar to anyone who's used Presto. But in addition to that, you have every cluster comes pre-built with, if you'd like, a Hive metastore, as well as a pre-connected S3 bucket. So we've converted Presto into a little mini data warehouse where you don't have to worry about the catalog. You don't have to worry about the data storage. It's pre-integrated, if you like. And you have all these endpoints that are readily available to you. So let's take a look at Superset here. And so you have access to Superset, which allows you to essentially define your databases. All your catalogs can be connected here. And this allows you to do joins across a range of data sources. If you want to join across Glue data and Hive data or RDS data, you essentially can define these different the different catalogs and connections, and then access it using dashboards or your SQL editor that's pre-integrated here. So you see that I have a range of different connections for the different catalogs that Presto has been connected to. It gives, I have access to, I've picked, this is my Presto sandbox. And so I have a default schema. This is the Ahana managed Hive that comes built in. And you have then have access to creating external tables in managed tables, in whatever format you want. The last thing I'll show you is how easy it is to connect data sources. So you can connect a range of data sources very easily. Here you see that I have 4 different data sources defined. I have Glue, MySQL, and others. Adding a data source is extremely straightforward. You essentially pick the data source you'd like, given the credentials, click on Add Data Source, and it essentially will create that catalog properties file for you, restart the cluster for you, and all of that is taken care of by Ahana. For each one of these data sources, you have visibility into which clusters it's connected to. So for example, this Glue is connected to my sandbox and 2 other clusters which are currently not active. And it's very easy to go ahead and start up a cluster. Now that this is in pending state, once it comes up, we'll be able to use that Glue catalog that was pre-attached to it and access data. So you can stop, restart clusters very, very seamlessly. With that, I want to hand it back to Gary, just to show maybe a quick view of how you are able to maybe join across different data sources.
Can you see my screen okay, Dipti?
Yes.
Okay, yeah, so really quick, I know we're out of time here. I'll just show you very quickly, as Dipti said, I have a number of clusters set up here. I have a sandbox or dev cluster and a prod cluster. I have 3 R5 2XL nodes running, which has an 8:1 vCPU to memory ratio. So an average size cluster, to some people, maybe 3 is a large cluster. To other folks, maybe 100 nodes are a large cluster. So 3 fairly beefy nodes. And I've set up, I have just a basic query here. So this query is querying across 3 data sources. I have set up a Postgres RDS data source. So I have a Postgres database running. I have Redshift, which is our data warehouse. So I have a data warehouse connection. And then I have a Glue data catalog, which is a Hive compatible metastore with the underlying data in S3. I've distributed the movies ratings database. If you're familiar with the movie ratings off of Kaggle, it's a 27 million row movie ratings database that's used often for testing. So I've distributed the tables across these 3 data sources. And then in Ahana Cloud, I'm able to query across 3 of these. So I've written a simple query, performed some basic calculations just to get it to run a little while, looking for particular keywords within a text string in the movies, and then particular cast members, and then compiling that into rankings and averaging the ratings and their popularity. So we can run that, and then as Dipti said, I'm sure everyone on the call is familiar with Presto, and you've seen the Presto engine running. So you can see these errors because it wasn't fully started, but you can see that finished, and we can drill in and take a look at that. Clicked on the wrong one there, sorry. That did finish. Not sure why I got an error. I did get a result. I think I'm disconnected from my cluster. I got off my VPN, I'm sorry. But you can see that it returned a result in 11 seconds. So it chewed through 3 different data sources, a data warehouse, a database, and a Glue metastore on S3. 27 million rows, and it was able to come back with the computed results in about 11 seconds. Obviously, adding more nodes would make that much faster.
Great. All right. Thanks so much, Gary. Amit, that's our session for today.